Okay everyone, I am Sri Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. The live session 5. Okay, everyone, let's start this session.
Yes, sir.
I have choose some question and it's, number 4 also, and after I give you suggestion to some answer 5th. Here the question number first. An inherent current limiting solution for a diode bridge rectifier capacitor filter circuit is shown in figure below. The MOSFET requires minimum gate source voltage of 12 volt to remain in ohmic region. It means remains to on. That is able to reduce the power loss of the MOSFET. Okay. As the state, the ripple in the output voltage of the rectifier is 23 volt, affecting the MOSFET drop. What should be the ratio of R1 by R2 for the flawless operation of the circuit? Supply specification is to 30 volt RMS value. This one given as RMS. AC voltage, it means you can say V is equal to Vm sin omega t. And what is Vm? Vm is Vs. Vm is V RMS into root 2. 230 into root 2 into 25 volt approx. 25.26. Given the question for the gate triggering or to on the MOSFET, it required a gate voltage of 12 volt continuously. It means this voltage is 12 volt. If this one given as a 12 volt, then MOSFET will be on and this circuit completed to ground, and the capacitor start to filtering the output voltage. If a MOSFET is off, it means the capacitor is not connected to the ground, then current will not be flow. So the circuit is not completed anywhere. It means it required 12 volt continuously at the gate of MOSFET. Then this voltage is given 12 volt. It given the then what is you have find, then what value of minimum value of total output of a rectifier that can on the MOSFET, keep the MOSFET continuously on at a minimum voltage of output rectifier also. And what will the minimum value of output of rectifier? In this condition, you know about the waveform. The supply voltage sinusoidal, and if capacitor will not present, then this one voltage appear on output, same as input voltage and positive circuit. the capacitor is present in the circuit, then output voltage depend on the capacitor voltage. If you take this one is a capacitor voltage, then this one on, charge the capacitor, after that is discharge here, and this time period will be charge, and then one discharge. Then you can say yeah, this one like that. Output voltage, ripple is given. It means the minimum voltage and maximum voltage. -73 volt. This voltage is 73 volt. You can say this one VM1, this one VM2 can take. Approximate output voltage can take like average of the both voltage VM1 and VM2 divided by 2. So an approximation voltage of output. And it should be a 12 volt, this gate voltage, when a minimum voltage of voltage found on the output of the rectifier. Then what will the minimum voltage? Minimum voltage is peak value minus a ripple voltage. Then output minimum voltage, peak value at Vm minus the ripple voltage, delta P naught. Vm is 230 into root 2 minus 73 volt ripple voltage. Into 50 volt proc. This voltage appear on the both R1 and R2 resistor. This one, to take this one V1, this one take V2. Then what will be the V2? You can take a voltage divider. V1 plus V2 is total voltage. Then what will be the V2? Same resistance divided by total resistance. Your total voltage. If you calculated this one, you have required the voltage of 12 volt here. In V1 is same as resistance of R1. This voltage, remaining voltage, this one 12 volt is required to 252 minus 12 volt. This one 240 volt. Then it's asking about the R1 divided by R2. It's V1 divided by V2. You take this one and find R1 divided by R2. 240 divided by 12, the power is 20 volt. Sorry, not volt, 20. The ratio of R1 divided by R2. It means you have to take the ratio of R1 by R2 is 20. You take R2 as a 1 kilo ohm or 100 ohm, like a highly resistive, because of the, if you take a low resistance value, then current will flow like that and losses will increase. And 20 times of R1 to R2. Okay. Question number second here. A rectifier circuit is protected from the inrush current using a series resistance of 200 ohm. And operating at a steady state, the rectifier is connected from 230-volt main supply and drawing 0.5 ampere current. The RMS current is given, sinusoidal current at the unity power factor. It has output ripple of 20 volt and the connected across 500 ohm resistive load. Then what will the operating efficiency of the rectifier? You know about the efficiency is output power divided by input power. In percentage, it means multiply by 100. If you take this one as a bridge rectifier, the RS is given and output connected as a filter capacitor and resistor of RL. RL is given 500 ohm and RS is 200 ohm. Then Vs is given 230 volt as RMS voltage and IS RMS also given 0.5 ampere and power factor is 1. Same waveform in this one. If you take as a output voltage, you find like that. This one is a maximum voltage, this one is minimum, VM1, VM2, and output voltage VM1 plus VM2 divided by 2. And first to find a VM1. What is VM1? VM1 is a peak value of supply voltage. Then if but here resistors present, it means some voltage drop occurs here also. Then what will the input voltage of this one? That is up here on the output of peak value. Then what will the peak value here? That peak value occurs on the output also. And this one peak, I mean it means this one peak Vm minus peak drop of this one. Can say this one Vm1 is equal to Vm minus Im maximum value into Rs. Vm is 230 into root 2 minus Im is given 0.5, then sorry, the RMS value, then Im maximum value root 2 into 200 the RMS resistance. We calculate it, then we find 183.84 volt. Then VM2 is VM1 minus delta V0, what is the ripple voltage. The ripple output voltage is given 20 volt. Then take a 20 volt, 183.84 minus 20 volt, 163.84 volt. Then output voltage VM1 plus VM2 by 2.847. This one is voltage of output voltage. Then what will the average voltage? Average voltage it means in between them. This one, a straight line like box. It's an output average. Then output power. 12 output power V output square divided by A resistance. It 173.847 square divided by R 60 watt. Input power is Vs Is into power factor. Power factor is given like 1, Vs is given 230, RMS current also given 0.5, means 150 watt, 115 watt. Then efficiency is output power divided by input power into 100, and percentage efficiency you can find 52.5%. 60 divided by 115. The efficiency of this converter. The next question, a rectifier circuit is protected from the inrush current using a series thermistor. Thermistor means the negative temperature coefficient. If you increase the temperature, then resistance will be decreased in thermistor.
Sir.
Yes.
Sir, in the last problem, question 2.
Yeah.
Sir, for calculating this power, only this RMS value should be taken. Sir.
Yeah, you should take the RMS value, but here the difficulty to take RMS value, that's why I have take average as possible. Because of this one.
Sir, actually this Pin,
Yeah.
Pin is some source voltage into source current into power factor.
Yeah, this one P input. The input power factor is given up 1. As a unity power factor and RMS current also given.
Questions.
Yeah, in the questions, yeah. Dying at 0.5 ampere RMS sinusoidal current at unity power factor.
Okay, sir.
The output voltage is DC voltage, then you can assume that it's a DC voltage, RMS and average is the same approximately. But AC in AC system it will not be the same, and other waveform.
Okay.
But the DC voltage you find of RMS and average for the same quantity.
Since ripple is there, there will be a difference, but we can approximately taking both are equal.
It is not that much difference between RMS and AC because of this one. This waveform occurs on the output like
Yes,
this only.
Okay, they will be approximately
Difference
more equal.
Yeah, that's why. If you are output is like this one, then you can you should find the RMS voltage for the calculating of the power.
Okay. Anyway, for input we are taking only average. Sorry, RMS.
RMS. Input voltage is AC voltage, na?
Okay.
Next question is given, the rectifier circuit is protected from the inrush current using a series thermistor with a cold resistance of 100 ohm and hot resistance of 40 ohm. Thermistor is negative temperature coefficient, means if you increase the temperature, the resistance will be decreased. The rectifier is connected from a 230 volt main supply, drawing a 0.4 ampere RMS total current during a steady state, and output is connected across 500 ohm resistive load. The inrush current value during startup is 5 times of the input current, and output ripple voltage value is 5% of the startup voltage drop across the thermistor. The given inrush current value during the startup 5 times of the input current. Input current 0.4 ampere, 5 times the RMS current, inrush current. It means 2 ampere. Then the output ripple voltage value is 5% of the startup voltage drop across thermistor. Delta V naught ripple voltage is 5% of the startup voltage drop. Voltage drop means current into inverse current multiplied by resistance in cold. Because is given the startup voltage drop. Means in starting resistance will be cold, not hot. Resistance, and we will multiply by 100 is equal to 200 volt is the ripple. Sorry, it means this one of 5% of 5% 200, it means 10 volt. What will the voltage output rectifier? Output voltage Vm1 and Vm2. If you find the Vm1 plus Vm2 divided by 2 is the output voltage, then what will the Vm1? Vm1 peak value here, this one value. The peak value of same resistance is also present in the series of the rectifier. It means some voltage drop occurs here. Then V1 peak, then you find a peak value of input voltage minus I in voltage current into RT. You find in the SD state, it means hot resistance you could take because of the, if you draw running the rectifier, then the resistance will be hot, heated. Vm is 230 voltage is 230 volt given minus I input voltage is given 0.4 as the in the steady state, 4 into RT is the hot voltage into root 2. Because of this one at the maximum you find in this one root, so this one root 2 minus IS 0.4 into root 2 into resistance. Hot resistance given like a 40 ohm. You can calculate this one, or and this is one 40 ohm. Is 302.64 volt. This one also Vm1 and Vm2. Vm1 minus ripple voltage 10 volt is given, means 292 volt. Then output voltage is Vm1 plus Vm2 divided by 2. In middle of this one 297 of 6. The output voltage of this rectifier. Next question, which are the correct statements from the following options? Low power factor leads to higher line losses.
Sir, why you are consider, sir, why you,
Yeah. Yes.
sir, why are you considering only VM1 and VM2?
Peak weight
What
voltage
about
of
VM3, VM4?
no. This one VM2 means not it will not harmonious component. This one V1 means maximum voltage, minimum voltage also. You can say this one V output maximum and this one V output minimum. Output maximum plus minimum divided by 2 is the average of that. This one is the output voltage.
Okay, okay, okay.
This is not a harmonious component. The low power factor leads to higher line losses as compared to high power factor for the same load rating. Power losses, you know about this. This one I square all, the series one, to supply power to the any load. Then I square all loss is the power loss. Actually, it means power factor. If you take a power P of Vs and Is into power factor. If a
Sir,
yeah,
excuse me. Sir, for the previous problem, we have solved, no, we got answer is around 299.
yeah, this one.
Yes, sir. Answer is yes. But in the solution, in our assignment solution, they are giving and the range is 200 to 215, sir.
200 to
215. I got the same
yeah.
answer.
Here some I think some confusion. You will take this one current is the nearest current.
Okay, sir.
If you take nearest current, then you can find this one.
Okay, even I got the same answer what you have got. I got it 300, but I got it as a wrong. That is why I am asking. But they have given us some other answers around 200.
Yeah, I think they are taking the nearest current here. But in a steady state, you can't take a nearest current. Na? Yeah, in a steady state,
Yes, a drop. We should take a drop.
only drop will take. Na?
Oh, yes, sir. Okay.
Yeah, yeah. If you take nearest current, then you find this one answer.
Okay, sir. Okay.
This one some confusion.
And here also it was like output voltage of a rectifier circuit.
What? Sorry. The showcase one.
Okay, sir. Okay, carry on.
This one is a power. If you power fixed constant, then now what will be the current? P divided by Vs into power factor. It means a current intrinsically proportional to power factor in constant power. Voltage supply voltage is same. This one depending on the power. If load is same, if decrease the power factor, then it means increase the current. If current increases, it means power losses increases. For the first question given, in rectifier capacitor filter, higher the power factor leads to higher current drawn from the input source for the same load rating. It means you decrease the power factor, then you increase the high input current. It will be correct. Yes. Second one, sorry. First one, low power factor leads to higher line losses as compared to high power factor where the same load rating. Yeah, this one is correct. Now, low power factor means if you decrease the power factor, load power factor, then current will be increased. If current increase, the losses increase. The second option in the rectifier capacitor filter, higher the power factor leads to higher current drawn from the input source. No, no, no. In higher power factor, the current will be low. Unity power factor can be achieved with non-zero value combination of resistor, inductor, and capacitor. You know about the power factor. Power factor is R by Z, and Z1 is R square plus XL minus XC square, where XL depend on the omega L and XC 1 by omega C. If you take as L should be greater than 0, C should be greater than, you adjust the frequency of both one. You can adjust this one will be equal. In a resonant condition, you know about that. In resonance condition, this one is equal and only resistance is present. In resistance present, is power factor to be 1 become 1 can be could be 1 if the frequency adjusted like that, XL is equal to XC. It means the unity power factor can be achieved, yeah, with non-zero value combination of the resistor, inductor, and capacitor. Last one, higher the conduction time of diode in rectifier capacitor filter, lower the voltage ripple across the output. You can understand from the waveform. If this one is the output voltage, V as input voltage, this one is the output voltage. If your capacitor is not present, if you apply the capacitor voltage filter apply, it given the in the question the higher the conduction time of diode. If a diode conduct a higher time, it means the this one like that. Look, this one is the conduction of the diode depending on the voltage of the capacitor. If capacitor voltage is low, it means the conduction time is more, and then ripple it will be also more, it not less. If you conduction time like this one here, then conduction time is less, it means ripple also less, only this ripple occurs. If conduction time increases, it means the ripple also increases, not a decrease. Higher conduction loss diode rectifier, so lower the voltage ripple across the output. No, higher the ripple of the output voltage. It's depending on the capacitor voltage. If capacitor voltage is lower, that means conduction time will be more, and ripple also increase. Now take a next question, like for a thyristor maximum junction temperature is 125 degrees centigrade. The thermal resistance for the thyristor sink combination are 0.16 degrees centigrade per watt, and C combination of case 2 sink. This one is the junction to case, and this one is the case to sink. Is 0.08 degree centigrade per watt. For a heat sink temperature of 70 degree, in case the heat sink temperature is brought down to x degree centigrade by forced cooling, the percentage increase in the device rating is 8.71%, and then value of x. Given the thermal resistance of junction to case 0.16 degree centigrade per watt, and case to sink 0.08 degree per centigrade, 8 degrees centigrade per watt. Maximum temperature of junction is 125 degree of a thyristor or any device, you can say that. And is ask about the for the heat sink temperature 70 degree is a normal temperature, but you can decrease the temperature by using a forced cooling. You can use a fan, with the fan, then forcefully cooling up x degree centigrade, 2x degree centigrade, then percentage increase in the device rating is 8.71%. Then the value of x. I mean, what is the for the heat sink temperature, with the device will be increase the rating. Device rating increase, it means heating effect occurs when I square or RT loss, the inertia I square into R into time. This one is a heat produced by the current I square or loss. It means if device rating increase, it means the current rating will increase. First one, then I would know power is I square, all losses is the power, if multiply by time is the energy, and current directly proportional to root of power. Then first one you can take K root P, P1. Second is given for when the forcefully cooling, then 8.871, 8.7 percentage increase. It means I2 will increase 1 point I1 plus I1 into 0.0871 I1. The given the temperature, junction temperature 125 degrees centigrade. We take like that, this one as a junction temperature. After that case, after that it will sink, then ambient. But it will given only junction to case, this one temperature. And what will the power flow? Temperature of junction temperature minus sink temperature divided by total resistance. Total resistance given in the two junction to case and case to sink. Junction to case, this one is given, after that this one given. Junction to case plus case to sink. And first time it is given a 125 degrees centigrade minus 70 degrees centigrade divided by this one 0.16 plus 0.08. Now to be the power, can calculate here. So approximately 229.17 watt. After reduce the temperature of sink temperature, if P1 is a, then what is the I1? I1 directly proportional to root of P1. If you take as a K, P1, K root, P1 is 229.17, approximately this one K into 15, I think 15.13. And what will the I2? K root P2, I2 is 0.1 into I1. And what will the I2? I2 is 1.087 into I1 means K into this one 16.45. Then what will the P2? I2 is equal to K root P2. And what will the P2? I2 is given K into 16.45 to K into root P2. Take a cancel light and P2 find like 270.8 watt. If P2 find, then you can say junction temperature minus second time TS2, this one given as X degree centigrade, divide the same, resistance will be same, find the value of X, you can easily find the value of X for 60 degree centigrade. It means if you decrease the temperature of a case temperature or junction temperature using a sink and a fan, cooling fan, you can increase the rating of the devices. by forcefully cooling, you can decrease the sink temperature. Sink heat sink is if you take a heat sink of any devices, then you can use a fan to cooling up this one. Many type of cooling system available. Then you can increase easily to rating.
Sir,
Yeah.
sir, the rating means all the forward rating and then the reverse rating, everything.
The reverse rating, it means the current not flow in reverse direction.
No, no, voltage.
No, voltage will block the actually heating occurs only by the current I square all losses.
Mm. Okay. So
It
only
means
the
the current
forward
rating
current.
will be increased.
Oh,
Voltage
sir, it will
basically.
be higher than the data sheet current, or
Yeah, you can use no the divided rating. It means you can in the ratings, the device rating data sheet, it will given a temperature. In which temperature this one the rating of current rating.
okay.
Yeah, if you can decrease the temperature, it will you can increase the rating of the current.
Okay, sir.
Voltage depending on the different things. I think depending on the combination of materials.
Okay.
Next question I will take in like the three-phase half-wave rectifier, 220 volt RMS, 50 hertz supply to resistive load of 10 ohm. The average power consumed by the load. Here the average power asking about the average power. Taken RYB. So resistance is given as 10 ohm. And diode will be here 22 this as a V or Vm sin omega t. He's asking the average power. Average power, it means you should find the RMS voltage of the output voltage of the rectifier. But here the ripple is very large. Then you should find the RMS of the output voltage. In three-phase system, you in a half-wave rectifier, three-phase half-wave rectifier. The controlled rectifier have in your syllabus. I think
No, sir, no, sir.
you
Only
want to
diode rectifier is there.
only diode rectifier, na? Yeah. Actually, diode rectifier is the uncontrolled rectifier. If you go for thyristor, the thyristor is the control rectifier. You can control the output voltage. If you all want to learn about the thyristor, I can explain also. Control rectifier also. If you all agree to that. Then OR phase. This one. 0 pi by 3 2 pi by 3 pi 4 pi by 3 so that 5 pi by 3 and 2 pi. Or VR and D1 will be conduct from here to here the maximum voltage, here to here, and now VR is maximum, then D1 will conduct, and Vy is maximum, then D2 will be conduct, and D2, so you know everyone, D3 here. Then output voltage same as the when D1 is conducted, then this one is the output voltage, and D2 conducted, then this one, like that. Then RMS value, find the RMS value of this one. You can take a single time period for a single pulse, because this one is the time period only. I think 2 pi by 3 is the time period. This one, because of this this waveform repeated to here after the 120 degree. Then find the RMS value of this waveform. RMS, you know, root of cos square mean integration of 0 to time square dt 1 by t integration. Time period 2 pi by 3, and you can take here 2 pi by 3. Where to here? This one is the pi by 6. This one is I think 5 pi by 6. Integrate to pi by 6 to pi by 6. 5 pi by 6. VL square, it means this one is R waveform. Vm sin omega t. You can take this pulse if you want to take this one pulse, then you should take a Y waveform, Vy, not a Vr. So we take a Vm sin omega t minus 120 degree. If you take this one pulse, I am taking this one pulse, it means Vm sin omega t V square into dt. Means if you integrate with respect to theta, then d omega t. 3 divided by 2 pi 5 by 6 to 5 pi by 6 Vm square into sin square omega. You know about the cos square theta? Sorry, cos 2 theta. Cos 2 theta means cos square theta minus sin square theta. Can also retain this one. If you take cos square theta is equal to 1 minus sin square theta, 1 minus 2 sin square theta. Then what will be the sin square theta? 1 minus cos 2 theta divided by 2 and replace this one from this one. Vm square you can common, cos 2 omega t divided by 2 to d omega t. And 2 common here, this one is 4 pi, then we find pi by 6 to 5 pi by 6, 1 minus cos 2 omega t if you integrate 1 as a constant with respect to d omega t, d omega t replaced by the, sorry, this one is omega t replaced by the 5 pi by 6 upper minus lower side, 5 by 6 minus 5 by 6 minus cos omega t integration is sin 2 omega t divided by 2 from pi by 6 to 5 pi by 6.
हेलो, हाँ बोलो।
धनंजय प्लीज माइक ऑफ
नहीं
है।
नहीं, कल लेके आऊंगा सुबह। नहीं है
धनंजय सर,
किसका, नेटवर्क का?
this one is 2 pi by 3 minus 1 by 2 is a common. First put 5 by 6, then find sin 5 pi by 3 minus sin pi by 3. You know about the sin pi 5 pi by 6 is minus root 3 by 2 and pi by 6 is 60 degree is root 3 by 2. Both are minus, you can add this one. This one plus 1. Take this one common as outside, then find 3 Vm is Vm into this one root 3, so by 2 into root pi, remaining of this one you can calculate under root this one, find 1.72. This one is the line voltage, root 3 into Vm, Vm is the phase voltage, and multiply by root 3, this one line voltage. and you can take a VML as a line voltage by 2 root pi into 1.72. The RMS of this one, if you calculate RMS value, you find 151 is a RMS. And what will be the power? Power is V output RMS square divided by resistance. This one 2.28 kilowatt. VML is given like 230 volt, 220 volt, and take this one. In the figure shown,
Sir,
yeah.
for finding an average power, you are calculating an RMS voltage and taking square, the RMS square by R would give us power, no sir?
Yes, yes, sir.
In the case of full wave bridge rectifier with a capacitive circuit, with a filter circuit,
No, this one not a filter circuit.
can you get?
Only.
No, sir. No, I'm asking you, sir. I have a doubt.
Oh, okay.
It's a doubt.
Yeah,
But we have a full wave bridge rectifier with a capacitive filter.
Yes.
In that case, when you're asked to calculate an average output power,
Yeah.
how do you in that case, how do we calculate an average output power, sir?
In that case, the calculations of RMS voltage of this one is very complicated.
Okay, sir. Triple voltage.
Yeah.
Okay.
That's why we take as a average, because of the ripple of this one is very less.
Yeah.
If you capacitor is will include the capacitor in the circuit, the ripple of this one is very less. That's why you can take as a average of this one also equal to the RMS, as a approx equal to the RMS.
Okay.
In that case, you can take average.
Okay, sir. Okay. There we take V naught minimum plus V naught maximum by 2 and take the square of that and calculate an average power.
Yes,
Here.
In that case, yeah.
In that case, the V average square divided by R plus V ripple RMS square divided by R, isn't it? If it is capacitor filter output.
No. This one V output is coming from the ripple, na VM1 plus VM2, which means ripple maximum minimum divided by 2. Then you could take V average only. Don't we take this one? I think we increase the power also.
No, in capacitor filter full bridge rectifier,
Yeah.
if we want to calculate the power, exact power at the output, then it will be average V output square divided by R plus V ripple RMS square divided by R.
Yeah, if you have a ripple of RMS,
If you are, yes,
RMS you can take. Not
yes,
average,
you can.
RMS you can take.
RMS can.
But calculating of RMS, that one is very difficult. That's why.
The ripple is, if it is very less, we can neglect for the practical sense. Okay.
I'll take a next question. The figure given below, all the ideal, the value of current. It means this one is a common anode configuration. In that configuration,
Sir?
Yeah.
Sir, in the last case, the same thing, the rectifier capacitor filter output voltage.
Yeah.
In that case, sir, when the capacitor is discharging at that time,
Yes.
the output voltage will be decreasing from some maximum value to some minimum value.
Yes.
Sir, what will be the nature of that decrease? Whether it will be a linear decrease or exponential decrease?
That was exponential. Can't be linear because of the capacitor is discharged. It means e power minus t by tau. Yeah, this one exponential. That's why you calculated of the RMS of this one value of whole value is complicated.
Okay, sir.
If you take a larger capacitor, then you can observe this one as a linear, but it's not actual linear.
Yeah, that's what I think. Okay,
Yeah,
sir.
this will not take true. In this configuration, in anode common configuration, so anode and this one cathode, then what will in the minimum voltage, then that diode will be on. And this one ideal diode, it means this one drop is will be 0. Then this one is a 1 volt, it means this will be conducted. If any one is a conductor in 1 volt, suppose this one is on D1. D1 is on, then V0 is directly is a 1 volt. Is connected to the 1 volt. If this one is a 1 volt, then all of diode will be in reverse bias, because of this one is a more than voltage. Cathode is the more than voltage of the anode voltage. In this case, only D1 will be conducted. And D1 conducted, then V output directly 1 volt. Then you can find easily current I, this one 5 volt minus 1 volt divided by 1 kilo ohm resistance for milliampere. In same configuration, if you reverse the configuration, in this question, if you reverse the configuration of this one, as I know, the anode cathode is replaced by the common cathode. In a common anode replaced by the common cathode in this type of configuration, then this one D3 will be on. In that configuration, D3 will be on, and then V output is the 3 volt. Then at that time the current will be 2 milliampere. No question. Assume that the supply voltage in the given figure below start decreasing from 30 volt to 0 volt, like that. It is not given the sinusoidal or triangular wave, but it decrease from 30 volt to 0 volt. The maximum supply voltage at which the Zener diode lost its regulating ability. This one is a 12 volt. If this voltage, Zener diode will be break down from this one the anode cathode. Cathode to anode, if you provide the greater than the 12 volt voltage, then Zener diode will be breakdown, and then this one regulate as a voltage of replace this one like a 12 volt, a voltage source like that, in reverse direction, reverse breakdown. You can see that if it have required more than or equal to 12 volt of this one voltage, this voltage appear on load side, and it means this voltage should be greater than or equal to 12 volt for regulating to output voltage of 12 volt.
Sir, the drop across the 100 ohm need to be considered.
Yeah, you can drop also consider here or both this one voltage. This voltage is same as this one voltage.
Yeah, that is okay, sir. 12 plus that drop across is 100K should be
Power
taken.
supply voltage.
Yeah.
So supply voltage. In that type of question, you should disconnect this one from the circuit and observe this one voltage. If this voltage is greater than 12 volt, it means that this one is a breakdown. If this voltage is not more than 12 volt, then this Zener diode will be not a breakdown. It will be in a reverse y direction only. Current will be not flow here. There is given the maximum voltage at which the Zener diode lost the voltage. If you decrease the voltage from 30 volt to 0 volt, then what is the maximum voltage that time? This one voltage, this one Zener diode will be stop the conducting like the voltage source or regulating the voltage. The relative voltage is the output, given the output voltage is 12 volt. You know, at which voltage? It will, in that case, then replace this one as an open circuit and find out voltage of this one. You can replace this one 100 kilo ohm find the out voltage of this one. This one Vs, both resistors are connected in the series, and you can use the voltage divider, and Vs into this one RL. Take this one RL as this one RS. RL divided by RS plus RL. It should be greater than or equal to 12 volt. In that case, it will be conducted behave like a voltage source, 12 volt. Regulate the power, regulate the voltage here, output voltage as a 12 volt. In below this one, it means the maximum voltage that will lose the ability of regulation. Then asking about the what is the Vs and at which voltage. RL is given 80 kilo, 100 kilo plus 80 kilo. Maximum is asking, it means it is equal. K cancel out. And Vs should be 12 into 180 divided by 80. Will be as will be 27 volt. At 27 volt, until 27 volt, the Zener diode will be regulate the output voltage as a 12 volt. In the below the 27 volt, then this one is be off. We have like a open circuit. It will not conduct and not break down. Then the whole of the voltage appear in the output. It will not be 12 volt, it will be more than 12 volt. Next is the Zener diode.
But then the current flowing will be lesser in that case.
When output voltage, yeah. If this
When
this one
the
is
supply
on,
voltage is 26 volt.
No, this is 26 volt. This one, it means this one is off. All of them flowing to the output.
Correct.
Yeah. If this one is conducted, it means some current flow, new current, current flow through the Zener diode. In that time, the output current will be less. If you take 27 volt. If you take a 26 volt like that, it means this one is open circuit. All of current flow to the output voltage. It will depend on the supply voltage. What is the supply voltage? That will depend on the
नहीं, supply voltage की तो बात है ही नहीं ना. अभी if you have two resistances here 180k,
yeah,
then that is limiting the amount of current flowing out.
yeah, yeah.
In fact, if the Zener is conducting, then more current will flow effectively. I mean, I'm trying to understand, figure out whether when will the current flow maximum from the power supply at, let's say 30 volt or 27 volts or 26 volt.
It depends. If you take 30 volt, this one is on with this one 12 volt. This one current flow like that. 30 volt minus 12 volt divided by 100. Okay. If this one is not present, okay, then whole of current.
And if you say, let's say 26, if you say supply is 26.
Yeah. If you take a 26, then this one current flow. Divided by 180.
So 30 by 100k is more, I think, as compared to 26 by 180.
Less current.
Correct.
No,
Yes.
It will depend. You can calculate this one. This one is only 18 volt. 18 divided by 100.
18 by 100.
It means 180 milliampere.
And this will be approximately 260 milliampere. Oh, 13 milliampere.
Yeah, 140
One-
approx.
130, 130, 140 million.
Yeah, 40 million.
Thank you.
Okay. The next question is given the 6 volt voltage, this one Zener diode VZ, you can say 6 volt Zener diode shown below has 0 resistance and knee current of this one is a 5 milliampere. In this one current flow, if you the Zener is a breakdown, then 5 milliampere current flow through the Zener diode. The minimum value of resistance R, so that a voltage across it does not fall below the 6 volt. It means this one will be conducted in reverse breakdown. In that case, the output voltage is regulated at the 6 volt, constant as a 6 volt. If this one voltage is less than 6 volt, it means this one is disconnected. And what will the I? This one is given if you on, I will sorry break down the Zener diode, and this one voltage is 6 volt. The current is flow like a 5 milliampere knee current, and this one is the I. You can find easily I is 10 volt minus 6 volt divided by 50 ohm, 80 milliampere. Remaining current go to the output. Total current is IL. If you take this one, IL is a load current plus IZ is this one, Zener diode. 80 milliampere. What will the IL? IL is 80 milliampere minus 5 milliampere is equal to 75 milliampere. Resistance would be V output maintained as 6 volt divided by resistance IL, current V naught is maintained as 6 volt, 25 milliampere in current flow. If you maintain 6 volt, then our resistance will be required as 80 ohm. This would be 80 ohm to regulate the output voltage as 6 volt. The next question, consider the circuit below. Assume the diode is the ideal. The average current passing through the resistor R is found to be 2 milliampere, and the value of resistance is equal to. Here the battery is given. If the diode voltage is greater than the 12 volt, then diode will be turned on. A half wave rectifier is given. This one is VS supply voltage. The sinusoidal. And take a VS VM sin omega t. The frequency is given 60 hertz. This one maximum voltage is given 24 volt. And battery voltage is 12 volt. This one is the battery voltage. This one is greater than 12 volt. In that case, the output voltage will be found and current will flow. Output voltage like that. Remaining is the battery voltage. And what will be the current? Current will be flow like Vs, this voltage minus this voltage divided by resistance. If you decrease this one 12 volt from 24 volt, then you find form like that, this one. That's one current will be flow. That current is Vm is Vs minus 12 volt divided by resistance. Then what will be the angle of this one time? You take this one theta 1, this one theta 2, and what will be theta 1 and theta 2 to calculate the average current. To calculate average current means I average 1 by time period, integration of 0 to time period into I into dt. Time period is total to 2 pi in half wave rectifier, integration of theta 1 to theta 2 only present current. What will be the current expression? Vm sin omega t minus Vb, can take away the battery voltage, divided by resistance. And what will be the theta 1? You can say Vm sin omega t equal to as a theta 1. This one is same as equal to 12 volt. Vm is given 24 volt. Then theta 1 sin is not 12 by 24, 30 degree. Then theta 2 same as pi minus 30 degree, 180. This one 180, same angle occurs here. (150°). Then what is the conduction time? Conduction have a total of 120°, according 2 pi by 3. Then find the average value of current. Pi by 6 to 5 pi by 6. Take Vm minus cos omega t pi by 6 to 5 pi by 6 minus Vb 5 pi by 6 to pi by 6. So the constant is a common, common. This one is 1 difference integration is omega t is replaced by 5 by 6 to minus 5 by 6. In that case, you can put a lower value first, and cos pi by 6 minus cos 5 pi by 6 minus Vb into 2 pi by 6, 2 pi by 3. This one root 3 by 2 minus this one is minus root 3 by 2. So add both one and you find root 3 only. Put in the value of this one Vm is given 24 volt. So this will multiply. So R is given. Sorry, R is asking about the resistance. (24 into root 3 minus 12 into 2 pi by 3). Average current given 2 milliampere. Can calculate others value. Only one variable is found on resistance. You can find it. This one is the price of 1.31 kilo ohm. Calculate by own, and you can find.
Sir,
Yeah.
if we are asked to find an average voltage,
This one.
yes, for the same problem,
Yeah.
from the average would be from theta 1 to theta 2 Vm sin omega t minus Vb by Vb
Yes.
omega t. From theta 2 to 2 pi, we have to take 12 and like that you should need to integrate like that, sir.
Yes. Yes. Yes.
From theta 2 to 2 pi, the voltage is 12 into d omega t. Can you follow that?
You can take like that 1 upon 2 pi
1 by 2 pi.
integration of theta 1 to
Theta 2,
theta 2 will be sin omega t. Same.
yes, Vm sin omega t.
Vm sin omega t
Omega t.
into d omega t plus theta 2 to 2 pi
Okay.
is the Vb into d omega t. This one voltage also present in the output. That's why. Take a theta 2 to 2 pi.
Okay.
Sorry, 2 pi plus theta 1.
Sir, I think
Yes,
we
sir,
are
that's
that
just plus theta.
right.
Yes.
Yes.
Yeah.
It is, so this first function Vm is just Vm sin omega t alone. Will this 12 volt will not come into account?
No.
Okay,
This one.
okay, sorry. That is only as a sinusoidal portion.
Okay. Because this one is the output. Na? If this one is greater than this one, whole voltage obviously. If you find a current, in that case, to minus this one.
Okay. Theta 2 to 2 pi
Plus theta 1. This one also, na?
Yes.
This one is 2 pi. This one is 2 pi, and 2 pi plus this voltage also.
Okay.
If next cycle occurs, then this one is present.
That only. Okay.
Then theta 1 also present. In that theta 1 to theta 1 is the total time period. Yeah. What is
In
the
this
average?
case, isn't this similar to maybe cell phone charging like thing, maybe primitive circuit that they could use?
Yes.
So would this be like cell phone charging circuit?
Yeah, you can assume that one, but in the cell phone charging it is very different from this one. There are a thyristor available, and this one is the back-to-back converter uses in the cell phone charging.
Okay.
Yeah. But you can take this one is battery charging only for high battery charging. It's a simple charger.
Lead acid for lead acid.
Yeah, you can say. This one is a source in impedance, a source resistance.
So using a transformer, they would do it.
Yeah, using transformer, you can step down the voltage up to approx 12 volt. If you have a 12 volt battery, then step down to 18 volt or 20 volt like that. After that, you use a converter. After direct you can use as a battery, but here you use a converter, DC converter. This DC converter is used to charge the battery after that. And mobile charger is different. Mobile charger you can charge from DC and AC both. The configuration is different. We will use that back-to-back converter. First one is step down, and after that use as AC to DC, DC to AC. After that you find the DC, AC to DC, like a 3-step. In that case you can charge from AC and DC both. The same next question is on a battery, a simple battery. Asking about what the average current of the diode. Average current of the diode same as the average current of the battery. Same thing, you can find this one. Vs is given 100 sin omega t, is on the 50 volt as the battery. Same thing you can use. This one 15 volt, this one 100 volt. This one output voltage, and this one is the current waveform, theta 1, theta 2. Here also if you find theta 1, then 100 sin theta 1 is equal to 50. Same, I think theta 1 is equal to 30 degree. Same the theta 2 150 degree. In average of diode current, diode current is same if you diode on in between them. In one diode, in full wave rectifier, in that case the diode current will be different. Diode current will be different because of the another diode also occurs here. In that case, on here, in that case you can calculate only this one. You should calculate this one only. This one only the diode current. But in half wave rectifier, diode current is the same as the output current.
So, sir, if we had back-to-back or like anti-parallel diodes, the diode which was connected anti-parallel would not make any sense, right?
Yeah, this one not any sense. This one only is AC signal, AC system.
No, meaning because there is a battery here, it doesn't make any sense.
No, if this one is a 0 volt like something, in that case battery supplied the voltage in that one case. This one is a sinusoidal, this is like that.
Right.
If the sinusoidal voltage is less than the 50 volt, then current will be flow from output to this one, output to input.
Right.
Through the resistance.
Okay. So then it will be a different analysis then.
Yeah.
Because then it will also happen between 0 to 30 degrees and 150 degrees to 180 degrees as well.
Yeah, in that case you use like inverter, can behave like an inverter, but it will not inverter. Inverter is because DC component alag, different type of DC system and AC system.
Combined together. Something.
Yeah. But in that case, this one is not a sense of in diode. If you remove the diode, and that time the same configuration will find. But in the thyristor, in case of thyristor, like that, if you have a thyristor in both the directions, in that case you can regulate the voltage, output voltage. Output voltage is also AC system. If you have a load and you have an anti-parallel diode as anti-parallel thyristor, in that case you regulate the voltage, output voltage. It means the voltage regulator, our AC voltage regulator, thyristor will present IGBT or thyristor in anti-parallel. In that case you find like that output when this one is triggered like that. In that case this one is on because of the reverse direction, and this one is signed occurs.
Right.
This one is a triggered point value as alpha, triggered angle. In that case, if you find the RMS voltage of this one is a reduce of the sinusoidal voltage in the say, supply voltage. This one RMS voltage is a reduce. You can say this one is a regulator. You also know about the thyristor. This one is if you only thyristor you have only thyristor. This one is not battery present, only if you take only resistance like this one. And also you can control the output voltage. And this one Vs, some angle of this one you can fire the trigger the thyristor, provide the gate pulse of thyristor, then you find like this one, this type of waveform you find in the output voltage. So is alpha. If you integrate this one and find the average voltage, output voltage, then you find Vm upon 2 pi 1 plus cos alpha. Like that you find the output voltage. You can, if alpha is 0, if you triggered here 0, then it will be same as the phase rectifier, half wave rectifier. If this one is 0, it means 1, cos alpha is 1. Then find the output voltage like that 2 Vm upon pi, sorry Vm upon pi. This one is the half wave rectifier, and the full wave rectifier 2 Vm upon pi is the average voltage. But if you have a thyristor, then you can control the output voltage. In full wave control rectifier, find this one cos alpha on a term also occurs here. You can control from the alpha. Output voltage will be controlled. That's why it is known as the control rectifier if you use the thyristor. And the if you use a diode only, then it is an uncontrolled rectifier. You can't control them. And another converter also, another semi-control or half control. Semi-converter of a half control rectifier. Half control rectifier, it means the thyristor and diode both are present. Yes. I think thyristor is not in your syllabus, but if you all want to know about that, I can explain it in another question, another session. If you all agree about that, I can explain this one in more detail. Okay, in this case, next session I will explain thyristor, RL load and RL load both, and observe what will the harmonics analysis also I do in next session of control rectifier, and what is the time power factor, and the power factor depend on what value. Okay, then the next question is given a half wave diode rectifier is on the figure. The load contains pure inductor of the inductance L is equal to 100 millihenry. Assume the diode is ideal. The ratio of RMS value of the output current to the average value of the output current. In this case, first to find the waveform of the output voltage and output current. For this one, do the analysis of this one circuit. Take as a Vs this one. The output when diode will be turned on, when this one on, then V output is similar to Vs. Vs is given as a Vm sin omega t. V output is a inductor, then L di by dt. If you integrate this one, find I is equal to Vm by L sin omega t plus some constant initial value. So this one is minus cos omega. At t is equal to 0, at omega t is equal to 0, I will be 0 when we will not supply the voltage. Then k will be Vm by omega L. So this is omega L. Sin omega t, if you integrate this one with respect to time, and find cos omega t divided by omega. Then finally current we find Vm by omega L cos omega t plus Vm by omega L. Can also written as Im is equal to Vm by omega L 1 plus cos omega t. So the supply voltage we turn on the diode. If you want to turn on when the supply voltage is connected, this one the current will flow like that. Then you observe the current flow as a 360 degree. Then output voltage is the same follow to the input voltage like this one. This one is the input current, and this is expression of the input current, and find the average and RMS value of this one.
But the diode won't stop after the half cycle.
It will not stop now because of the current
The
will not be
voltage.
zero. Inductor does not allow the sudden change of the voltage, a sudden change of the current. If we stop this one, in that case, the di by dt will be very high because of the time will be 0 in that case. Then di current will be very low. I think this one here 2 Vm by omega L. This is very high. Di by dt is very high. In that case, diode it can't. It could not stop the diode to conducting.
So whether we have a diode or not, then still the waveform will be same, right?
No. In that case, this waveform is not same. This waveform is a sinusoidal because of the inductor load present. Inductive load only.
Okay.
Is the AC system, na?
Right.
Yeah, the diode will be turned on here. The second, once it's 0 is connected. In AC system, this was not a waveform. This is the only AC, DC. In that case, you integrate this one from 0 to 2 pi only because the whole time period will be on. Then I average 1 by t time period is 2 pi integration from 0 to 2 pi Vm by omega L 1 plus cos omega t into d omega t. You common this one. You integrate this one to find 2 pi minus 0 cos omega t sin omega t from 0 to 2 pi we put this one 0, sin 2 pi is 0 and pi also 0, then I average is equal to Vm by omega L. You can also find from the expression. So one is present here, cos omega t is present here, cos and sin average value of one time period is 0, 2 pi, then average only this one frequency term and this one is the constant term. Constant term is the average value. If you have any signal, if a constant term is present in there, it means this one is the average value. In same case, you can find RMS. I is given Vm by omega L plus Vm by omega L into cos omega t. In DC term, this one AC term, you want to calculate RMS value, I calculate directly the DC term square plus AC term RMS square. Vm by omega L in AC system, Vm by root 2 is RMS, this one is square, and find a total RMS of this one, this waveform. You can common find 1 plus 1 by 2 or 3 by 2 and 1.22 Vm by omega L. Then value of I RMS divided by I average 1.22 Vm by omega L divided by Vm by omega L, so 1.22. In that case, in same case, if a thyristor is present in the place of the diode and conduction triggered at the 30 degree, then what will be the conduction time of the diode thyristor? It will be same 360 degree or less than 360 degree. Same calculus you can done when the thyristor is turned on at 30 degree. V output will be same Vs Vm sin omega t, and this one is the LDI by dt. And I is equal to Vm by L cos omega t plus k. Till here the both are the same, but triggered either 30 degree, omega t is equal to 30 degree, not a 0, because the thyristor is present, then omega t will is equal to, when at omega t is equal to 0, and this one is the initial condition of the inductor current, then I will be 0. Then this one minus Vm by cos alpha, in that case k is equal to Vm by omega L cos alpha. Then I will be Vm by omega L minus Vm omega L cos omega t plus Vm by omega L cos alpha. Vm by omega L will be common, cos alpha minus of cos omega t. In that case, this waveform will be, this expression will be occurs. This will be triggered here. And what value of this one will go? Current will be 0 at I is equal to 0 at alpha is equal to 0, sorry, omega t is equal to alpha. At omega t is equal to alpha, this one will be 0. When omega t is equal to alpha, it means cos alpha minus cos alpha is equal to 0. And again, when will be 0? 2 pi minus alpha. If we put here Vm upon omega L cos alpha minus cos 2 pi minus alpha, then it will be again 0. It means I is equal to 0 when omega t is 2 pi minus alpha. When not 2 pi 360 degree, it will not conduct a whole 360 degree. It conduct only 2 pi. This one is pi, so 2 pi minus alpha. To take this one is 2 pi minus alpha. If alpha is 30 degree and 30 degree, this one angle, then this waveform go like that. This one voltage, the current the same is, it will increase from here to this, like that. It will be 0. After that, this one alpha next cycle, so it will increase, and in that period it will be turn off a 0 current of inductor when triggered at alpha. If you thyristor will be in the coming in the picture, then the conductor will not conducting the whole 360 degree. Its conduction will be decreased because of a and pi at pi till the pi the conductor will be charged. After that, this one is discharged. In this one is the same time, and this one also same time, and same time is your charge and discharge inductor. And conduction time you can say this one is a conduction time, 2 pi minus alpha 2 pi minus alpha, this one minus alpha in this one time period. This means 2 pi minus 2 alpha is the conduction time. So 60 degree minus 60 degree, 300 degree only conduct. The thyristor will be present. If thyristor is not present, it means this current start increasing from 0. But the thyristor is present and triggered at a 30 degree or some other angle, then until and that angle will start the inductor current increasing. After the pi 180 degree, then this will be discharged because of this one. This way voltage will be reversed. The voltage is reversed, and this one is discharged. Okay, everyone, I am stopping here.
Sir, we have not discussed some problems related to the new assignment 6.
In assignment 6, this one BJT and
It is reversed means.
I think this type of question will present. Zener diode
See
and
that
BJT.
sir. And
BJT.
other some with current controlling, current limit control.
I think all of us solve this one. Even because of the
Yes,
BJT and the Zener diode only present in next assignment. Okay. No?
Thank you, sir.
Do you have any doubt? Okay, in next session, I will explain the thyristor control rectifier of R load and RL load.
Okay, sir.
Sir, inductor voltage is also reversed here.
Yeah, voltage can reverse, na? Voltage can sudden change in inductor, but current will be not sudden change.
Okay.
Yeah, voltage because of this voltage same as the supply voltage. If supply voltage is reversed, then this voltage, inductor voltage also reverse. Yes, because of this, if this one on, same as voltage, supply voltage.
Sir,
Yes.
sir, in the assignment 5, the last question, sir.
Assignment number 5.
Yes, sir. That is the last assignment.
Sir, and somehow I don't have access to these videos if they are recorded. I don't know where to look for.
Okay. I send you a link. So now I told you.
I am watching from my cell phone, so I cannot store that link that you are sharing. Would it be possible to share it on the course website somewhere or course link somewhere?
Yes, I think you in course website also share the link of all the TAs. You go to NPTEL website, you can find this. You can find
Okay.
this. Assignment number 5, the last question. This one,
Sir.
the voltage applied to the load is a 230 cos omega t plus 20 volt. Sorry, 20, and current drawn by the load is a 5 cos omega t. Then the power factor is asking, na? This one another question.
Sir, that question only.
In that question, the voltage is leading the current. It means current will be lagging. Current lagging, it means power factor lagging.
Okay.
This one. Because of voltage is plus 20 degrees, means voltage is the lead by the current, and power factor seen by the load only. If you calculate the power factor, it means depending on the load. Load means current. Current is lagging here in nature by the 20 degree, and cos 20 degree lagging is the power factor. It's okay?
Okay, sir. Okay.
And thanks to all.
Thank